Hey, Jackie B. Google here, shocking you and rocking you while I'm talking to you. You've made it to the OK Google Tell Me How webinar. We get started at 1:03. Wait for it. I see all you guys out there in YouTube land putting in the time. Jackie B. Google here. Hang in there. You will be rewarded. Risk it for the biscuits, y'all. We'll get started at 1:03. Special shout out to our friend and your favorite Ashley Harding, the moderator today. And another special shout out to the Florida man himself, Alan Ranciato. Wait for it.
Hey, can you guys hear me?
Yep, we can hear you, Alan.
Alright. I actually got one of those microphones. I just haven't tested it yet.
YouTube Live, thanks for waiting and being patient. I'm not saying it's easy. I'm just saying it's worth it. Go ahead and click subscribe while you wait.
How
We
about
do
now?
this every Thursday at 1 Eastern Time. And that's PM, not AM. Nobody's getting up that early. We get started at 1:03. 1 minute left, y'all. Enjoy this lo-fi copyright jam by DJ Quads. It's called Midnight Snack. Downloadable free on the internet. Just Google it. 45 seconds, y'all. Wait for it. Alrighty, that's it for me. I'll see you right back here next time. All cheesy jokes. Copyright whoever said them before I did. Now it's time for the first lady of the webinar. Take it over, Miss Ashley Harding. Have a great one.
Hello, everybody, and welcome to OK Google, Tell Me How. On this special edition, we will be talking about optimizing costs in Google Cloud. Yes, everybody, you heard it right. From a salesperson, we will be telling you how to cut costs in GCP. So get ready for it, because we have a very own Alan Ranciato to tell you all the tips and tricks on how to lower that number in your Google Cloud Console. As always, thank you to all of our fans chilling on YouTube Live. Please check in. We'd love to hear from you. And those who check in this week and register with your business email, we will be raffling off at random a Google Home Mini. So please check in, let us know what you think, and send us some love. And then, so for our next week's topic, just to give you a little heads up, we'll be talking about when will things change, forecasting demand with demand from Google Areas 120 group. So it should be a great time. It's going to be one heck of a performance. We have Nick Turner from Area 120 to give us the lowdown on demand. Like always, it's on Thursday at 1 p.m. Eastern time. So look forward to seeing y'all next week for that episode. And then a couple of housekeeping items. Everybody, if you have questions, please use the chat function. We have our moderators on the YouTube Live link that will send me your questions so I can ask Alan. So please keep the questions coming. We'd love to hear from you. And then, as always, please fill out our survey. Let us know how we're doing or what you want to see next. This webinar series is for you. So let us know what you think and what you want to see. And like I said, here is the link for you to check in. We really want to know how we're doing. We want to hear your great ideas on how we can improve or add some content. So please go to this link. And like I said, anyone who checks in will be with a business email will be entered in to win a Google Home Mini. And for those of you who are waiting on your minis, just want to let you know they have come in. So everyone's shipment's going out this week. So keep us honest. We do send those minis out. And without further ado, the man, the myth, the legend, our very own and our favorite CE, Alan Ranciato, will be talking to you guys about cost optimization. A couple quick and fun facts about Alan is Alan is a barbecue aficionado. We'll let him talk a little more about that, whether he's a brisket or ribs kind of guy. He's a home automation junkie. I've actually heard a lot of stories about how he does that. So that's a very interesting fact about Alan. And he's a professional social distancer. So Alan, thank you for taking on that profession. And maybe you can teach our others how to do that as well. But Alan, I'll let you take it away.
Thanks, Ashley. Can you guys hear me okay?
Yep, you sound great.
Cool. Let me take over. Do you mind if I take the screen from you, Jack?
Go right ahead.
Go right ahead, Alan.
Right now. Anyway, thanks everybody for showing up. We are going to go through some really exciting stuff today. It's going to be how to optimize cost on Google Cloud.
I think anything you do will be exciting, Alan.
Having some issues. All right. There we go. And anybody, you guys might remember me from other really exciting topics like watching paint dry and watching grass grow. But seriously, why am I here? I'm here to talk to you guys today about this. Cloud costs are too high. One of the things I like to tell people is that the cloud is not going to save costs if we just make it into a more expensive data center. We can save a lot of money, and we can always save more money. So what we want to do today is go through some of the high priority items, some of the high priority things that you might be doing with Google Cloud and how to make it better. So for the next 45 minutes, we're going to go through knowing what and where you're spending money, how to optimize costs on Google Cloud, and then a quick Q&A. I do have a lot of material, and I'm going to go through it kind of fast, just because it may not be the most exciting topic. But if anybody has any question, please ask me, jump in, throw your question into the YouTube chat. Ashley will read them out, and we'll go through that. So if anybody needs me to go back, after the presentation is done, I will be showing some links and some things within Google Cloud. I've got some reports and some demo type stuff that might be interesting, that if anybody wants it, just fill it out in the survey and ask it in the survey at the end, and we will send you guys those links. So first thing we want to do in going through here is define the problem. So we need to gather the data. We don't want to just go in and start tweaking buttons and tweaking different things. We want to figure out what we're doing. Do we want to gather the data by project, by application, by line of business? How are we actually tracking costs for what we're doing? If we're doing it by GCP product, we can do it on compute engine, on cloud storage, on BigQuery, by facet, compute versus storage versus networking, to know where we're actually spending the most money, and by platform, if we're using GKE, raw Kubernetes, VMs, serverless architectures. We have a lot of tools within the platform to allow you to go through and actually determine where you're spending your money. We can also do it by application, services, and platform. So by leveraging some of the features of Google Cloud, we can go through and determine who is using what the resources are being used for. And things just don't go into a black hole. And then based on time. So we can get peak times, we can get peak time of year, peak time of day, when we're actually doing things, to be able to make proactive decisions on how to do things. So in identifying that, then we need to define. In defining the problem, identifying our targets. So we want to look at big spenders. We want to look at wasters. We want to see where we're actually making money off of the services we're using. Non-production capacity that's not actively being used. Do we want to go through our test infrastructure and determine, do we need this operating 24/7? Our dev infrastructure, can we allocate these things dynamically? Are people abusing it? Is somebody running a cryptocurrency miner somewhere in our infrastructure? It happens. And then anti-patterns. Are we doing things that we shouldn't be doing? Are we designing over-architecting our infrastructure? And then take that one step further and look at the constraints. What are our actual goals? Is there an ROI at what we're trying to do? Opportunity costs, how much are we going to build into this process? And is it going to cost us more to fix the problem than it is to actually have the problem? And then look at the effects on what we're doing. Performance, availability, complexity, velocity. Is tearing down dev infrastructure going to slow down our application development teams and make it a longer time to market for our applications? And then considering abuse and the Cobra effect. If anybody's not familiar with the Cobra effect, I'll cover that real quick. It basically, I forget where it is. I want to say Scotland or Ireland, but it dates back to a day where there was a bounty out for, it was Vietnam, I'm sorry. A bounty out for rats. And basically it turned into, people would go out and to prove that the rats, they were catching the rats, they would cut off the tails of the rats. And they had to show that. And so they would do that, but then they would ended up cutting off the tails of the rats, going out and gaming the system by letting them go and procreate. So it comes into a kind of the fix is worse than the solution, gamification of what we're trying to do, and abuse. And so you really don't want to go down that path. So one of the big things we can do is organize this by organization. So kind of set up what we're trying to do. You know, one of the big features in GCP is setting up quotas and budgets for and limits for what you are doing and what you're spending. And we can set up budgets to look at what we're spending. We can do it by product, we can do it by team, we can do actual triggers and notifications, and then we can automate these things. So not only set the thresholds to send emails and just alert people, but actually send things onto PubSub and automate this process. And I'll go into that a little bit later. As a part of that, and actually I'll go into that a little bit now, we can do proactive control. So, you know, setting up that billing admin and creating those budget alarms, pushing things out to Cloud PubSub, and then firing off functions, which then call APIs to say turn down resources, to throttle them, to suspend them, to cap spending on different things. So this is just kind of a little example architecture of what we can do as part of that process, and calling, you know, the Google Cloud hold on one second. We may be having a YouTube live. Let me see if I can optimize my screen a little bit better here. Sorry, I've got a little note that it was hard to see. Any better, Ashley?
Yeah, I think you're good.
Oh, cool.
Yeah, keep rolling, Alan. I'll work on it as well.
All right, thanks. So if you look at this flow, we've got you know, budget alarms going off, pushing out to PubSub, firing off functions, which then can then do notifications, can call APIs, to call Terraform, to call Cloud Deployment Manager, to suspend resources, and then, you know, that impacts your end users. So, you know, as things get out of hand, as we start hitting thresholds, or as we don't need things, we can do that. And then there's visualizing data. We have a lot of tools within the system, and if anybody wants these links, we can send them a little bit later. But we have a BigQuery pricing code lab, and as a part of that, we will teach you how to go through and export all of your billing information into BigQuery. And coming out of that, you actually get this dashboard, or can build this dashboard that will show you all of the cost breakdowns of everything you're doing. So it's not just our regular billing information, not just our billing screens that show you, okay, this is what we're spending. But you can actually go through here and optimize by team if you're doing chargebacks, to see it by project, to see what you're actually spending, and drill through some of these items, sort by cost metrics, projects, GCP services, who's doing what, and what you're actually searching on and what you're actually spending. So, you know, it's one of the big things. This is something available on Google Cloud on our website, and it shows you how to reuse this report for your billing account. And it'll take you through the process to go through, not just looking at our standard billing reports, which are fairly valuable, but it'll take you through a little bit more detail on some of that stuff. And then part two of this here today is implementing optimizations. So taking the data that you've really just looked at, taking the data that you've found, and how do you fix it? So taking the right sizing approaches, and looking at it as part of the organization. You know, what are the targets and goals of the organization? What is our total cost of our ownership? Do we want to see utilization, cost savings? You know, how do we make changes? And that's a big part of our DevOps culture, is how do we make changes across the organization? How do we make sure that teams own the infrastructure that they're building, that they are responsible for it, that they are actually going to own the process, and own that cost, whether it be charged back or whether it be some sort of incentive to make it better. So gamifying it is a big part of making that change. Mandatory pre-launch cost and architecture choice reviews. Obviously, that does go a little bit beyond the DevOps culture in saying now we've got gates, but we do have to do and think about that trade-off there. And then considering nudging. Anybody who's not familiar with nudge theory is a way to push people towards a certain decision. So if you see here, there's 2 urinals. As part of those urinals, you can see there's little flies painted in the urinals. People sit there and they think, well, let me aim at the fly. So I'm nudging people into doing that. The same concept goes with choice architecture, and that's part of that. It's giving people choices. So rather than saying, okay, go out and now create yourself 3 VMs, the first thing as a developer, I'm like, well, I need 120 gigs of RAM, and I need this giant VM. I may not need that. So rather than me having to figure it out myself, offer small, medium, and large, and just offer those little steps. And then if somebody wants to go outside of that box, outside of that constraint, they can. And then operational. Think about leveraging automation as part of this. We talked in a little bit earlier about setting up the proactive, turning up, turning down, utilizing our discounts that we have on the platform. And that is committed use discounts and sustained use discounts for anybody who doesn't know. Sustained use discounts on our platform do not require reserving instances. They kick in automatically. So as you use things, they automatically kick in. Committed use discounts require just going in through the platform and allow somebody to say, okay, I am going to commit to X amount of processors, X amount of memory on X amount of machines. And if you were to look at the pricing, and this is generally available to everyone, say I want 128 cores and I want a whole bunch of memory. If I were to do this for 1 year, you can see right here in the console, I'm going to save that much per month.
Hey, Alan, it's a little tough to see just because of the size. Can you tell us what the savings there is actually?
Yes, I can. And let me actually see if I can zoom in even better.
There we go.
All right. So from a 1 year perspective, looking at this, without a discount, I am going to spend $6,400 a month on what I just did there on a general purpose G1 machine. With committed use discount, that's about 30% savings. If I were to do that same thing on a 3-year duration, just waiting for it to update. There we go. On a 3-year duration on that discount, I am going to save closer to 50% per month. So
Wow.
being able to go in and just set up those discounts yourself without having to talk to your FSR, not that nobody wants to talk to Ashley, but to be able to do that and be able to see with it and play with it, what am I going to do? What if I want to add GPUs to that discount? What if I want to add local SSDs to that discount? It allows you to go through and actually do that yourself.
Alan,
yeah, go ahead, Ashley.
we actually have a quick question. Can SUDs and CUDs work together?
Sometimes.
Tough
The answer is they're not natively stackable, but if you talk to your FSR about committed discount and actually doing those committed use discounts, things can sometimes happen. So I'm not going to put words in your mouth, Ashley, but yes.
So everyone watching, moral of the story is, if you do have questions when it comes to discounting, please let us know so we can get you in touch with your FSR, whether that's myself or someone else in the area. So let us know if you have more questions around that. But love the questions, guys, and keep them coming.
Cool. The next thing I have on here are infrastructures, code, and schedulers. So we want to think about actually going through and creating everything as code. So with Terraform, Deployment Manager, whatever your tool of choice is, let's not have people going in and clicking buttons and creating infrastructure. Let's do it as code so it's repeatable. So when we're not using it, we can take it down. We can use schedulers in GCP to access the API, to turn down things when we're not in use. If we have a whole bunch of test infrastructure that we're not using today, we're not using it on the weekends, there's no point in leaving it up and running. Somebody shouldn't have to remember to go and do it. We can do enforcing tagging on resources and to set up accurate chargebacks and showbacks. And I showed you that report earlier. A lot of that is based on labels, which is really important in the application or in the platform. And then we can see real-time insights and alerts. So we can use Forseti, which for anybody not familiar, it's a policy management platform, open source that runs on the Google Cloud platform that enforces policy across the platform. So if things start to drift, you get configuration drift, you get people doing certain things they shouldn't be doing that are outside, not necessarily malicious, but also malicious. They're outside of the normal context of what they're supposed to be doing. We can enforce those policies automatically. And then looking at recommendations, we do have recommendations on all of our infrastructure. So whether it be in managed instance groups or individual VMs, if you were to go into your VM instances, and these are somewhat new, so they don't have anything, but just looking here, it'll show you recommendation. Here, meaning we're a tad bit behind. It'll show you in your VM instances your recommendations, and it'll say this is undersized, we can make it smaller and save X amount per month. Same thing with managed instance groups. The other option are the recommender APIs, and these are great if you haven't seen them. It's part of the G-Cloud SDK. They are APIs that can be called to recommend VM sizes, to recommend IAM policies based on what certain users have done over the last X amount of days. I think it's 90 days. VMs infrastructure that's not the right size, infrastructure that doesn't need to be up and running, that's not in use. And it actually runs through and it'll send out a really nice JSON report that you can drop into any sort of reporting tool to look at and to make changes to.
Hey, Alan, quick question.
Yeah.
How granular are the controls for users being able to create resources?
They're extremely granular. So we can do it there's 3 different ways to do IAM permissions, and we can do the primitives, which are basically admin, user, viewer, and my terminology may be slightly off, but we can also set it up on a per compute basis, and then we can also go really, really granular with custom roles. So we can do our primitive, we can use our predefined roles, and we can use custom roles. And we can do that to groups rather than users. Never, ever do it to users, always do it to groups, which are your IAM groups, which essentially are Google groups if you're G Suite users and you're used to that. So yeah, you can drill it down to, I can create a compute engine instance, but I can't create a network for it. You can go really, really granular if you wanted to, and it all depends on what you're trying to do. Additionally, you can only activate certain APIs if you want. So if you want to hold back access to BigQuery, or you want to hold back access to other things, you can do that as well.
Alan, do you think it's a good recommendation to only have specific people who can create things like that?
It depends. I wouldn't want, an intern creating things in production. At the same time, I don't want to stifle development. I want people to have the ability to spin things up, to move fast, trust, then verify, that sort of thing. So put controls in place so that we can see what's happening. Make sure there are guardrails that we're not going to take everything down, but at the same time, don't stop people from moving forward.
So Alan, quick question from from me. um, you just presented on operationalizing. Have you seen examples where folks are segregating, you know, production and staging, and that those have different rules and policies and so forth?
Absolutely. And a lot of that depends on how your organization runs, how you want to set that up. The Google Cloud Platform does set up at organization level, but then folders and projects underneath that. All of our resources are allocated by project, and resource permissions are hierarchical. So we can set multiple projects, whether we want a project by domain, so we want it by what it does, or a folder by domain, and then projects by environment, or we want environments, folders, and then projects by. So it can go either direction, but separating those things out is a great way to do that. And it does depend on what your infrastructure looks like, what your organization looks like, how agile you are, how much you want to move forward, and how much you want to interact between environments also. So, for instance, if you're just running GKE, wouldn't necessarily recommend it, but I've seen it in action before where people just use namespaces for everything. And so it is one large cluster. Definitely not the direction you want to go from a large scale operation. But if you wanted to use the same infrastructure for dev and QA and staging even, you could, and it gives you that opportunity. So, we do have the ability to break all that up, set permissions at the project level, at the folder level, at the organization-wide level, and just let them cascade down. So it's fairly easy to manage. All right.
Okay.
Next thing here is operational areas to address. And this is your priority one workloads. There are a lot of things within the platform that we can do, and a lot of little buttons to push and tweaks to make. But the four big areas to look at are compute, networking, storage, and BigQuery. So compute, and I'm going to move a little bit faster here. For compute instances, so think about compute. We're talking about GCE, we're talking about VMs, we're talking about GKE. We're even talking about serverless. So thinking about how you're using those and the different things you can do. One of the big things is using preemptible VMs. For anybody who is not familiar with those, they're at about an 80% discount over regular VMs. The caveat to them is that they can disappear. So they last for about 24 hours. And they can disappear really at any time, giving you, I think it's 30 to 60 seconds of notice. As a part of that, you have the ability to put in scripts to run different scripts when they're shutting down. So key use for those are batch processes, things that you can recover from, image processing, different processes that you don't necessarily need something very, very stable. They can shut down at any given time and you can recover from and just pick up where you left off. Another really big use of that can be within Kubernetes or GKE. So your underlying clusters, you can create clusters that are a mixture or multiple clusters where you've got regular permanent VMs, but you also have preemptible VMs mixed in. So as part of your scaling architecture, you can use preemptible VMs and save a lot of money when you're building out these clusters and actually building out these compute resources. Infrastructure automation, we talked about that a little bit. So making sure that everything is actually done by code. It's very auditable by doing that. VM suspending and resuming for hot standby. So this is somewhat new to the platform, came out last year. Rather than shutting down machines, we actually can suspend things. So if you have workloads that you don't need the machines running, but you want to save state, it suspends them and saves that state in a temporary state. So when you go to turn it back on, it's really just a standby and resume. So you're not restarting the machine, you're not restarting from scratch, and it's a greatly discounted rate for having those machines there. Efficient VMs, making sure you're right sized, making sure you're using memory optimized where you need to be, making sure you're using GPUs where you need to be, TPUs where you need to be, making sure the machines are actually built for what they're supposed to be used for. Labels are huge. So labels, when I showed you that report earlier, they're as easy as going in and creating an instance, and when I were to create a VM instance, being able to put labels on that VM. And in putting labels on that VM, I can just add labels, and those labels, I can tag them for teams. I can tag them for people. I can tag them for projects. I can tag them for environments. They're basically metadata that's available on those VMs. So when I run reports later, I'm able to actually really drill down into what these things are used for, who's using them, why they're there, and even when, just to be able to see all of that stuff. So really, really key on the platform. And you can use labels for pretty much everything. There is something called tags also, and those are network related. So a lot of people confuse those a little bit. The networking tags are for firewalls, and to say I can tag this machine and now this firewall rule will apply to anything with that tag. So rather than having to know IP addresses and things like that, you can go that route. So a little bit different, a little bit off topic, gonna move on. The other key is serverless. Let's look at what your applications do. Why are we using VMs when we might not need to? So we're not just trying to lift and shift, uplift our data center, move a whole bunch of VMware machines into the cloud, and now we're just paying for a whole bunch of VMware machines into the cloud. Think about what these things are doing. Is it just a node service? Is it just a Go service? Is it something that just has to go make quick little calls? Can it be done with a function? Do I really need a VM, or just do I want to do a pay-per-use? So when I'm thinking about my application architecture, do I want to do some sort of re-architecting while I'm doing this? So starting with the smaller size VM is one of the things. We do want to scale horizontally when we build out these infrastructures. So all of our managed instance groups can scale. Same with GKE, can scale. So think about, how many VMs do I actually need? Do I need 20? Can I run with 2 and then just let it scale up? And then think about backup and DR strategies. So thinking about what we're actually doing with our backups. Do we need to back everything up? Do we need to back up ephemeral machines? Do we need to have a DR environment if we have multiple copies? Are we running multi-regional? Are we running an HA? How exactly are we doing these things? There's a lot of different changes and a lot of different ways we can look at things, which are different than in a data center.
Hey, Alan.
Yes, sir.
Question for you. Yep, it's me, not Jack. So in your experience, you have a lot of expertise on this, and you mentioned earlier, what are the big spenders and what are the big wasters? Curious, what are those?
Machines that are left running is really one of the big things. So VMs that are left running when nobody is using them. Oversized VMs are one of the biggest things. That it's legacy. I'm used to running in a data center. I've come to the cloud. I stand up a whole bunch of machines as an operations person. Think about it, difference between development and operations. Development moves fast. They want to get things out to the customer. They want to move to production. Operations says, I've had the server running for 366 days. I'm over a year. I don't ever want it to go down. I want to keep that streak going. I don't want to take this infrastructure down. It just needs to be stable. So coming in with that attitude and looking at things like that, you're thinking, okay, well, now I have this infrastructure. I'm just used to it. I keep it up and running all the time. It's always available versus using it on demand. So I'd say that is the number one big thing for saving costs and looking at costs. Is just runaway infrastructure that's not being used and doesn't need to be up and running.
Gotcha. And in your past experience and what you're seeing, do you ever see teams inside businesses that are purpose for optimizing these infrastructure costs, or is this left for the dev team to have to do? What are you seeing?
There are. It's a lot of that comes through whether it be office of the CFO, CTO, having little teams that can go through and actually optimize that. Ultimately, it usually flows through architecture, and the architecture groups are the ones who are sort of putting in those guardrails and putting in that process of how we want to actually optimize that, and what we want to do, and how we want to build once we move to cloud. Let developers work on actually writing code. We don't want developers worried about the infrastructure, but we also don't want them abusing it. So we need to hand them something that can be easy and really get out there they can build with.
Hey, Alan, question for me. I know I'm killing your flow here, but I hope you don't mind a few questions. This is one that I actually got from a customer via email who's paying attention. We had Kelsey Hightower on a few weeks ago. One of the statements that he likes to make is, I see a lot of folks using cloud, but I don't see a lot of folks leveraging cloud. And I think that makes a lot of sense around cost. The question actually was, is there any examples that you can think of customers who have really made this migration and saved a lot of cash by quote unquote leveraging the cloud?
Yeah, I'd say there definitely are. When you start looking at data center costs and the cost of VMs, serverless didn't exist when you're running locally. And if it did, it was because you're running something like Pivotal Cloud Foundry and spending a good deal of money for that. So looking at, in this slide right here with the serverless on GCP, is how do we start migrating off of our legacy infrastructure, our legacy way of doing things, and saying, okay, this is quick and easy. Let's use a cloud function. It's more of a utility type thing. Or we just have a front end app. Let's push it to App Engine. We don't need a lot of different things. We don't need to size a huge database when we can use Cloud SQL. Let's use those managed services that are really on a pay per use. BigQuery is a huge one in leveraging cloud and leveraging that. So one of the examples I like to give whenever I'm talking about data warehousing is usually you go in and you decide, all right, I'm going to build a data warehouse. I'm going to procure a whole bunch of hardware for it. I'm going to stand all that hardware up. I'm going to start building my data models. I'm going to do cubes. I'm going to do all of the different things. I'm going to build schemas. I'm going to start loading up data. 6 months later, I've yet to really run a query. And I'm sitting there, I'm just designing it. And I've got all of this hardware sitting on the shelf costing me money. About 3 months after that, we start testing things. And about 3 months after that, I've actually got users starting to onboard and starting to use things. So I'm about a year into it, and I've been paying for this all along. With something like BigQuery, I'm paying per use. I'm paying for my queries. Storage is cheap. You're going to keep that data anyway, especially when you start using federated storage with BigQuery, pulling data from storage buckets and utilizing, and we'll talk about cloud storage lifecycles in just a second, but utilizing things like that with BigQuery, and now you're not paying for anything but the actual usage. So as you're building this thing out, as you're looking through it, you're saving a ton.
And for our customers that are listening, if you're wondering, well, what other companies in my specific industry have done something like this and moved to GCP and were able to optimize costs? If you go to cloud.google.com/customers, you'll be able to read our customer stories and how people have done things like Alan's talking about and implemented it in their infrastructure, and really hear from those teams on why they did it and how they did it. So just a tidbit for everyone who's listening.
Cool. Serverless, I've talked about it a couple times. Really, it's just taking away that whole infrastructure management model, saving costs. I do like to really start to compute the cost of an engineer and how many engineers it takes to build something and how many engineers it takes to maintain something. Especially security. What is the cost of a breach? That's when things really start getting out of hand. So using serverless really is a pay per use model. You're only paying for it as using it. From a programming model, it's service based, it's stateless. It really allows you to move forward without thinking about a lot of the minutia that would normally cost money. Infrastructure. The second caveat here, the second aspect of what we were talking about is networking. So, ways to save money in networking. Look at your networks. We offer a premium and a standard tier network. So our premium network is the default. It's what you want to use for production. But when you start thinking about dev and test environment, we have a standard routing, standard tier networking, which is still on our network, but it is a bit cheaper. It has different routing. So it not necessarily for production. It doesn't have quite the throughput for production, but considering for dev and test, it will save you a good deal of money. Interconnects. So people look at the cloud and they think, everything's free. And then they look at their egress bill. So having data actually leave my on-prem data center and go, or actually the other way around, leaving Google Cloud and going to my on-prem data center, it costs money. So using interconnects to actually create a dedicated line between that will save a good deal of money over the long run. And cost of the interconnect to get it all set up is usually minimal to what the savings is going to be over time. CDNs. So getting your images, getting your resources, their web pages out closer to your users. Not serving them up from your compute resources, not using that if things are already cached. NICs. So anybody who doesn't know, you can add virtual NICs to our machines and to our resources at no additional cost. And then using aliases. So we actually allow you to set up aliases of IP aliases within the network. And using those aliases for VIPs. So when you are launching an application, you want to switch a VIP from one version to another, do canary deployment. If you're not using Kubernetes, for instance, using aliases is a good way to do that versus and save costs versus using load balancers. Third thing is storage. So when you're going through storage, think about what you're storing, how you're storing it, what your buckets need to be used for. So how long am I going to use this data? How do I need to use this data? Where does it need to be stored? How often am I going to access this data? Does it need to be regional versus multi-regional from a availability standpoint? Can it be nearline, code line? Do I need to access it monthly? Do I need to access it yearly? Or can it just go in the archive because it's audit data? I need to keep it for 7 years, but I'm never ever going to look at it. Each one of those different levels of storage costs less and less as you go down for storing it. Access may cost more. It's an inverse relationship, but the less you're going to use it, the more you're going to save. So you can actually set up storage life cycles. And this image here on the right shows you how to set it up and say, okay, I want to actually move this, move it to code line, move it to nearline, or delete the data after a certain amount of time. You can also set up bucket locks to lock data in there. So your lifecycle won't actually apply to certain data that you don't want it applied. So just safeguards around there. And then there's BigQuery. So it's the last one I'm doing here. Looking at storage, how we want to use BigQuery. There's a lot of savings in there. And we talked about using federated data, how we want that storage to be, avoiding duplicated data, using streaming inserts. They can get expensive. You may want to look at things like streaming inserts and using a pipeline and putting data in storage buckets and then ingesting it through there. And then backing up into recovery. And then also looking at your query processing. So being able to query just the data you need. So using partitions, using clustering within your databases. And then as you start actually using BigQuery a lot, looking at flat rate pricing. So with flat rate pricing, you're actually just buying a certain amount of slots for the month and usage slots on BigQuery. So versus being charged by the terabyte or by the megabyte on your BigQuery usage, it goes through and it's unlimited flat rate just on the amount of data you're querying. We can visualize cost. So there are dashboards. You can create your own dashboard. We have another code lab. And if I were to go in there, I can see all of my projected usages, my total gigabits billed, my average slot usage to determine, is it time for me to go through and say, now it's time to look at doing flat rate pricing. So start looking at these things. We offer a ton of these dashboards. They're all in Data Studio. You can copy them. You can do different things with them to make them your own. And Data Studio, for anybody who doesn't know, it's a free reporting tool on our platform. So it will hook into BigQuery and it will visualize all that data for you. And then thinking about serverless options for data also. So BigQuery is serverless. You're not paying for that infrastructure. It's on demand or a flat rate. PubSub, anybody who are Kafka users, it takes a bit of infrastructure to run it. Message queuing, PubSub, totally serverless, no maintenance, no ops, message queuing, Cloud Data Flow. So Cloud Data Flow is based on Apache Beam, and it spins up resources as it needs them to run pipelines for you. So as you need to do data transformations, data loads, different streaming things, you can use data flow without having to build out an entire infrastructure to do a lot of that. And Cloud ML. So we've got a lot of ML resources rather than writing your own things in TensorFlow, having to create machines with a whole bunch of GPUs to do a bunch of processing and learning. Taking advantage of our ML tools will allow you to use the APIs and not have to worry about your own resources to do that. Everything else, there's a lot of things I talked about earlier on the platform, a lot of different ways to save. These are just some of the other ones. Observability costs, Stackdriver, if you're keeping a lot of logs, if you're capturing flow logs, a lot of times it's good just capturing a little bit of it or doing it on an as needed. So you can turn them on, tune them up. Same with firewall and NAT logging, same sort of concept there. And then, what you want to do with raw logs. Do you need to take those logs back on-prem? Can you save them in storage? A lot of people think from an audit perspective, we need to bring them home. Not necessarily the case. So something to think about from where you're storing your data, how you're using your data. Can we put lifecycle around it? Cost of security. Think about security tools, what you're running, how many rules you have, how complex things are, and then just the cost of availability in general. So this was another one of the programmatic approaches I had talked about earlier, to go through and set your budgets and then call functions and call Slack. Notify app owners, not just billing admins, about things happening. So throttling, suspending, capping spending, and this I showed you earlier, with turning up and down resources as a part of doing that. And then just wrapping up. So general best practices, use labels, 100%. Use labels everywhere. Cost optimization, we talked about that stuff. Compute engine, Stackdriver, cloud storage, BigQuery, networking. There's a ton of tools. We offer a lot of dashboards, code labs, free learning on how to do these things. Quick labs training, we do have that. And then cloud functions, how you can use functions more appropriately within the platform, not just for serving up code, but using them to clean up unused resources, doing things, kicking off things with Cloud Scheduler. So there's a lot of different functionality we can do. And then we also have a lot of videos on cost management on Google Cloud. So we can send you these links, just fill out the survey, and then really just next steps moving forward. So you want to make sure you label your resources. Look at those P1 recommendations. That's where you're going to get your biggest bang for your buck. So compute, storage, BigQuery, networking. Absolutely take a look at those things. Then just start monitoring. Not knowing how you're using it. It's not going to help you to tweak a bunch of buttons, but not realize there's something over there on the left that isn't actually running or is running and you don't even know about. And then just repeat. So it's the DevOps model. It's just iterating. How do we repeat and just really stay engaged? And talk to your TAM, talk to your FSR, talk to your CE. We can help you. And when all else fails, there's always money in the banana stand. That's it. That's all I have. Hopefully that was helpful.
No, we've had quite a few questions, Alan. One I just wanted to address really quickly because I couldn't type it fast enough to share with Ashley. The folks are asking for our slides from this presentation. I think they see this as a great checklist of things to do. We will add a link to the slides on the YouTube channel for those who are asking.
Yep, and for those who are asking as well, if you're looking for the slides, please put it in the survey. We can let you guys see it that way as well. This way we know exactly who wants it, and we can help with conversations around it as well.
Yep.
And then one of the questions I got, Alan, was how can I move VMs from one region to another if I've committed for these VMs? Is there a way to not to break the commitment and still move VMs from one continent to another?
There is. So
Tough questions from me. I'm sorry.
no. Part of that, for as far as the commitment goes, you may want to discuss with your FSR. VMs can be moved. We can move them around across projects. We can do it across organizations. Gets a little bit hairier, but we can do it with snapshots and just move them across storage buckets, which makes it a little bit easier to do that. So either backups or snapshots of those VMs, or images. So a couple different ways we can go about it. As far as the commitments go, talk to your FSR. That's the best way to do it, and we'll figure out. It could be different use cases across different customers and different setups. So I don't want to commit to one way or another, and we'll just determine what needs to be done and make sure everybody's taken care of.
Yeah, and to piggyback off of Alan, your FSR team is here to help you guys, whether that's save money, optimize. We want to be a family, want to help you guys when it comes to scaling with Google Cloud. So don't be afraid to ask these tough questions when it comes to cost. We want to help you guys as much as possible. So reach out to your FSRs and your CEs and really just ask, like, how can you guys help me more? And we love doing that sort of thing. So don't be shy. We want to hear from you.
Yeah, Alan, one question I got actually from a peer who was watching was a lot of what you have shared is on PaaS services that using platform services or serverless tools, you might want to call them that. Can you talk about the type of percentage cost savings, like a BigQuery versus a Teradata install, or a full VM versus a cloud function? Like how much do folks expect to save?
It depends. and I hate to go down that path, Jack, but it depends. It is an economies of scale. So at some point, it may make more sense to stand up a VM or a Kubernetes cluster than use a function or a PaaS container. So when I start looking at Cloud Run, for instance, Cloud Run is our Knative implementation of serverless. So it is a container-based. It can run on its own and scale to 0. So if I want to use Cloud Run and I just want to pay for what's actually consuming or what it's consuming, I can do it just like a function, just like an app engine. But it's a little bit more powerful as it's a bring your own runtime. You can run pretty much anything you can run in a container, you can run in Cloud Run. So it might make sense when I'm starting out just on a usage perspective. Let me test it out. Let me run it just as a standalone, let it scale to 0. At a certain point, I'm going to start saying, all right, I need this thing. I'm spending more in those individual calls than I would be if I were to just host this on my own GKE cluster. So, there is an economies of scale with a lot of these things, and really having that reporting data and knowing how you're consuming every one of those services and where that data is coming from is what's going to help you.
Cool, fair and fair answer. Like that's a journalist's answer. Like only the truth from Alan Ranciato.
The answer is it depends. It's always it depends.
Yeah, it's good that is, because literally the company I work for, Google, would put me out of business out of a job because people would just Google the answer. It wouldn't matter. So.
And also for those listening, if you're curious, like how much cost savings could be if you move something over or whatnot, your FSR teams have tools to help you guys with that. So like I said, as a salesperson, we love to talk. So just hit us up. We can help you in any way when it comes to optimizing costs. And like I said, I am a salesperson, and we put on a webinar today to help you save money and spend less with us. So trust me, we really are here to help you guys. And I don't think we have any more questions. So Alan, I wanted to say thank you for taking the time to speak with us today and give us the inside scoop on how people can save money with Google Cloud. Just a quick little update for everyone again. One, please check in. And so this way you can be in the random raffle to win a Google Home Mini. And second, don't forget to register for next week's episodes. Like I said, we'll have demand from Area 120 talking about how to forecast demand with Nick Turner on Thursday at 1 p.m. And then for the following week's schedules, please check out the landing page and register for the next week's. And like always, we are so happy that you guys join us each week and can't wait to see you next week. So thank you so much for attending and for spending your lunch with us, and can't wait to talk to y'all next week.
Thank you, Ashley. Thank you, Jack. Thank you, everyone who joined.
Thank you.
Thank you, Alan. Goodbye.